Okay, we're going to look at the other two types of equations. If you remember in the last video, we looked at log equals log. We looked at log equals a number, but a little bit fancier than that, where we had to do a little bit of work to get the log by itself. All right, so for here, get log by itself. These were the square problems, and these were the circle problems. All right, so next we're going to look at the heart problems, where we've got, well, I didn't mean that, the problems where we've enclosed them with a heart. So these problems are going to be similar to this one in the sense that we've got logs on both sides, but in this one we just had a single log. In the heart ones, we've got log either plus or minus another log equals a log. All right, so let's confirm that that's what we've got here in 18 and 20. These are the two that we're going to do together. So I would say, yeah, log plus log equals log. Here we've got log minus log equals log. I'm not really paying attention to what's in here. I just want to see that it matches this basic form right here of two logs either added or subtracted equaling another log. All right, well, when it was just log of something equals log of something else, or maybe we should say this, log of x equals log of 37, that was so easy to solve, right? But when we've got two logs here, then it's like, well, I don't know, what do we do? Do we bring one log over to the other side? Well, that's still going to get two logs on this side and one log on this side. We don't know anything about, we can't say that log of this plus log of this, we can't do like x plus 7 equals 37. It doesn't quite work that way. So this is where we're going to go back to our condensing rules that we just talked about a little while ago. I can take these two logs and use the condensing properties to condense them into a single log. All right, so that says if I have the sum of two logs, that's the reverse of the product rule. Remember, the product rule says if I have two things multiplied together, a log of a product equals the sum of two logs. If I have the sum of two logs, that means I can condense it into a single log. So x times 7, I'm going to write that as 7x instead, equals log of 37. All right, so I just condensed that using our condensed formulas, and I got this. Right, now it takes us right back to this type that we did on the front. Right, so I've got log equals log. Again, because log is 1 to 1, I can say if these two logs are equal, then these must have been equal. I can't get two y values that are the same with two different x's. All right, so that means that 7x has to equal 37, and that x equals 37 over 7. And again, you might be thinking, oh my gosh, there's no way I'm going to be able to check that. All I want you to do is to confirm for me that if you plug that back into the original equation, not some version of it like, the condensed version, back into the original equation, that you are not taking log of 0 or a negative number. All right, so if I plug in 37 sevenths here, oops, not 37 thirds, 37 sevenths, I am not taking log of 0 or a negative number. So this is not extraneous. Right? Again, it doesn't answer the question of whether it's correct or not, but it does answer the question of whether it's extraneous, and it's not. So you can use the answer key to check that, or you can actually try and do it. So 37 sevenths plus log of 7, is that equal to log of 37? Well, if I condense these, what is that mark? If I condense these, I do 37 sevenths times 7. I can condense it into 1. 37 sevenths times 7, is that equal to log 37? And when I multiply these two together, I get log of 37 equals log of 37. Again, that's not my concern as much as that you check to make sure you're not taking log of 0 or a negative number. Okay, let's take a look at number 20. It looks scary, but it's not really. All right, so again, it falls into this form of its log of plus or minus another log equals a third log. And again, these are all the ones that have hearts around the numbers. So we're going to use the same technique that we did in problem 18, and that is convert it to a log equals log by condensing, right? So in this one, we say, oh, look at this. We've got log of x plus 6 minus log, sorry, I skipped the base 9. Log base 9 of x minus 6, x plus 6 minus log base 9 of 6 equals log base 9 of 2. The condensing property said if we have a subtraction, we're going to turn it back into log of a single quotient. So we're going to have log base 9 of x plus 6 over x. Right, that's the condensing it using the quotient rule, equals log base 9 of 2. Now we use the rules that we had for the log equals log, which says that if I get two logs that are equal to each other, I must have been taking log of the same thing. So that tells us that x plus 6 over x must be equal to 2. Right? Hopefully you would see this and think that you should cross multiply. So I'm going to cross multiply, and that gives me the equation 2x equals x plus 6. I'm going to subtract x from both sides, and that gives me x equals 6. All right. I'm going to go back up here, and I'm going to check in every single log that has an x in it to make sure that it doesn't make any of them negative. So we've got log base 9 of 6 plus 6, that's fine, minus log base 9 of 6, that's fine, because I'm not taking log of a 0 or a negative. If one of them fails, it's extraneous. It doesn't have to say, if it works in every one of them except one, it fails, all right? So it has to work in all of them to actually be a solution, right? So anytime you're doing any of these problems that have the hearts around them, condense first, and then solve like the log equals log problems. Oops, maybe you couldn't see that. Condense first, then solve like log equals log problems. All right, so that's the third type, and the fourth and final type that we're going to look at is where we have the triangles, all right, and that's log plus or minus a log equals a number, all right. So hopefully you can see that we're going to use some of the strategies that we learned in this type, and then some of the strategies that we learned in this type. So when we use the log plus or minus log, we'll use the strategy here where we condense first, and then once we condense it into a single log, we'll use the strategy here, which is to turn it into an exponential. So get log by itself, then turn into exponential. All right, so let's take a look at this one. I picked one fairly straightforward and one doozy down here. We're going to do 19 and 24. All right, so again, I have log base 8 of 2 plus log base, wait, what did I say? Log base 8 of 2 plus log base 8 of 4x squared equals 1. So since I have multiple logs, I need to condense it so that I get it into either this form or this form up here. All right, so let's use our condensing rules. Again, if we have the sum of two logs, it must have come from the log of a product. So this would become log base 8 of 2 times 4x squared, and that's now equal to 1. All right, so this is log base 8 of 8x squared equals 1. Now, once I have it as log equals a number, I turn it into an exponential. So this right here is the base of the log. It's going to become the base of the exponential, and then these two flip-flop. So it becomes 8 to the first equals 8x squared. And then I'm going to divide both sides by 8, so I get x squared equals 1. And then I solve that and I get x equals plus or minus 1. All right, I have to check to make sure that it is not going to make something where we're taking log of 0 or a negative number. I do not have to plug it back in here because there's no place to plug it in. It's just log of a constant. But I do have to plug both of them back into here, so we'll do it one at a time. So it's log base 8 of 4 times 1 squared. Well, clearly that's positive. All the numbers involved are positive. But then for the next one, I would do log base 8 of 4 to the negative 1 squared. Again, don't forget the parentheses around the negative 1, or you might accidentally conclude that this is extraneous. Negative 1 squared is positive 1. 4 times positive is 1 is positive. So this is also okay. So both of those work. All right, last one here. I'm saying this is a doozy because it's a natural log one. And it just makes it a little bit trickier. A, because I think you lose your intuition. If you remember, we talked in class that natural log means the same thing as log base e. We don't know a whole lot about e, other than we know it's about 2.7. You have a lot more intuition with something like an 8 here than you would with this. So I feel like it just kind of freaks people out. And because it doesn't simplify like this, because it's an e, we just end up with a messier solution. So let's do it though. All right, so we've got a log minus a log equals a number. That's why it's in the triangle family here. And again, as with the last type, we're going to condense it first into a single log. Because it's a subtraction, that means that it must be a quotient. So we've got natural log of negative 3x minus 1 divided by 7 equals 2. Again, don't write natural log of this divided by natural log of this. That's not the case. It's natural log of the quotient. So 2 logs condense into 1. Okay. So now we need to rewrite this from logarithmic form to exponential form. And in the previous problems, when we've done that, we've just taken this as the base, and we've rewritten it by flipping these two things. But again, if you remember, in natural log, no base shows up. You just have to remember that it's e is the base. So we're going to have e, and then this becomes the second equals negative 3x minus 1 over 7. You're just going to leave the e in it, so don't be tempted to put that into your calculator. Just leave it alone. All right, it's just a number. All right, we're going to solve by cross multiplying again. So this is going to give us 7e squared equals negative 3x minus 1. So we add 1 to both sides, so we get 7e squared plus 1 equals negative 3x. We divide both sides by negative 3, so we get x equals 7e squared plus 1 over negative 3. Let's check it. Again, we don't have to check in here because there's no x in it. There's nothing to check here. So it's really just here. We need to make sure that when we plug that value in for x, that this becomes positive. So we're going to do natural log of negative 3 times 7e squared plus 1 divided by negative 3 minus 1. That just looks gross. Okay, so we're going to simplify this a little bit first. Negative 3 and negative 3 cancel out. So we're left with natural log of 7e squared plus 1 minus 1. Plus 1 and the minus 1 cancel out. We've got natural log of 7e squared. And this is positive, right? E is positive. We're squaring it. It stays positive. We're multiplying it by a positive number. So this we'll be taking natural log of a positive number. So this is not extraneous. Again, you'll see examples of extraneous when you go to do the worksheet in the workbook. Okay, please let me know if you have any questions. Bye.